Most people are completely overpaying for sheet metal fabrication because they choose the wrong technique. The same part gets quoted at wildly different prices depending on which box you checked on the RFQ form. And 6 minutes, you will know exactly which sheet metal fabrication technique matches your design and your volume. At Haizol, we review thousands of sheet metal inquiries every month from buyers sourcing custom parts through verified Chinese factories. We see the same mistakes on method and tolerances over and over, and the teams who avoid them reliably pay less for the same parts. Laser cutting vaporizes metal along your design path, so there's no dies, there's no punches, just a beam following your CAD file. Now it's best for complex shapes from one prototype to around 3,000 parts, where there's a 0.5 to 6 millimeter material. It does not make sense when you're making thousands of parts with standard round holes, because laser cuts one at a time while punching can hit them all at once. CNC punching rams shaped tools through sheet metal at high speed. That's best for more than 1,000 units that are dominated by standard hole patterns like ventilation grills, mounting plates, or server racks. And the per unit cost can drop 40 to 60% below laser at volume, but it does not work for free-form curves or organic shapes. Bending converts flat cut sheet into a 3D part using a press brake. That's mandatory for any design that is not flat. Now the key design rules are that there's a minimum 1x material thickness for inside bend radius or the metal cracks. Minimum 2 to 3x material thickness clearance from holes or edges or features deform. Now standard tolerances, well, bend angles plus or minus 1 degree, bend to edge plus or minus 0.25 millimeters per ISO 2768 MK. Selected precision suppliers achieve plus or minus 0.1 millimeter on holes after DFM review. Welding joins multiple sheet metal pieces into assemblies. MIG for thicker material, TIG for thin precision work, or spot welding for overlapping sheets. Now there's a critical note here, not all sheet metal shops offer in-house welding. Many outsource it, adding markup and lead time. The filter for in-house welding capability before sending RFQs. Finishing covers deburring, powder coating, anodizing, and plating. Specify it in your original RFQ. Adding it after gets you a 20 to 30% markup and 3 to 5 extra days. Always specify deburring for any part humans will handle. Outdoor or customer-facing parts need powder coat or anodizing in the spec from day one. Geometry first. Curves or complex shapes mean laser. Standard holes and simple shapes mean punching is an option. Volume second. Under 500 units, then laser wins. 1,000 to 10,000 with simple geometry, punching saves 40 to 60%. 3D part means add bending with correct design rules. Multiple pieces mean add welding with in-house capability filter. Outdoor or customer facing means add finishing to the original RFQ. Once you submit to the wrong technique category, you only see quotes for that method. Submit to laser cutting services with a 5,000 unit job that should be punched, and every quote will be laser pricing. You will never know you're overpaying. 5 common mistakes. 1. Picking laser for everything above 3,000 units with simple geometry. 2. Designing bends without checking the 1x radius and the 2 to 3x clearance rules. 3. Assuming all suppliers offer in-house welding. 4. Adding finishing as an afterthought. 5. Not comparing techniques before committing at your volume. Check your geometry, check your volume, pick the right technique before you request quotes. Screenshot the framework and drop design questions in the comments. I read every one.